Hi dear students, I'm Dr. Ahmad and welcome to School of Chemistry. Uh, this very tutorial is about concentration, and we have seen that students find it challenging when they do calculations related to solutions. We have tried to cover all these solution related calculations, and we have also tried to explain the concepts behind different terms like molarity, parts per million, parts per billion, normality, mole fraction, formality, and the interconversion of all these terms with each other. This is our first tutorial and we will focus on molarity here. As far as the concentration is concerned, as we all know that solutions are made up of solute and solvent, and the concentration is actually the expression of how much solute is there in a solution. Solute as well as solvent both could be in any physical state. They may be liquid, solid, or gases. And two important properties, mass and volume, are required to express concentrations in different terms. And these properties are like mass and volume. In order to have accurate concentration calculations, students must understand the relationship between different units of mass and volume. So we have mass conversions here. We have different units like kilograms, grams, milligrams, micrograms, and nanograms. And the relation between all these units is very simple, that we have got this multiplication factor here, that if we want to get grams from kilogram, we need to multiply the kilogram number with 1000 to get grams. And similarly, if you want to convert grams into milligrams, you need to multiply that gram with 1000 as well, and so on. This is the descending order of mass conversions. Kilogram is the biggest unit here. The gram is 1000 times smaller than kilograms, so 1 kilogram contains 1000 grams, and 1 gram contains 1000 milligrams, and 1 milligram contains 1000 micrograms, and similarly nanograms. Nanograms are 10 raised to power minus 9 grams because from nanogram to gram we have 1, 2, and 3 basically factors, and each factor is 1000 times, so 1000 into 1000 into 1000, we have 10 raised to power 9. So what you need to basically remember is that 1000 grams, they're equal to 1 kilogram. Similarly, if you are having milligrams, then 1000 milligrams equals to make 1 gram. Similarly, if you have 1000 micrograms, they're equal to 1 milligram. Microgram, milligram, factor is 1000, and so on. And these factors are very important because again and again students come across these conversions and they must practice hard enough to go through these calculations very smoothly. Similarly, if we speak of volume, we have various units which express volume in solutions. And in order to have a clear understanding here, you must see the sequence here, that the biggest unit which we are having here is cubic meter in terms of volume. Cubic meter is used industrially, and that is 1 cubic meter is equal to 1000 liters. Liters and decimeter cube are same units, and they can be used in place of each other. Similarly, milliliters and cubic centimeters are same units, and they can also be replaced with each other. As the sequence is concerned, cubic decimeter is equal to 1 liter, and 1 cubic meter contains 1000 cubic decimeters or 1000 liters. Similarly, cubic centimeters or milliliters are normally used in laboratory measurements. They are 10 raised to power minus 3 liters, and the relationship between liter and cubic centimeter is like this, that 1000 ml equals 1 liter. So if you have volume in liters and you want to convert that into ml, you need to basically multiply that with 1000. Similarly, if you have milliliters and you want to convert them into microliters, you need to be multiplied with 1000. So cubic centimeter equals milliliter, and the smaller unit than this is microliter, 10 raised to power minus 6 liter, and then we have another smaller unit which is nanoliter, 10 raised to power minus 9 liter. And nanoliter and microliter are associated with this factor, so that if you have quantity, if you have volume in microliters and you want to convert that in nanoliters, then you need to multiply this with 1000 and so on. So this whole sequence actually gives us a very detailed picture of how volume conversions are basically done when you are calculating solution concentrations. There are some solved examples as well. How can you convert microliters into, for example, nanoliters? So here we can see that nanoliter is a smaller unit and microliter is a bigger unit. So whenever you convert a bigger unit into a smaller unit, for that very conversion you need to multiply this with 1000. So here we can see 2.5 microliters is a given volume, and 2.5 multiplied by 1000 will give you 2500 nanoliters, and this 2500 nanoliter is the quantity, is the volume basically which we are getting from 2.5 microliter. So this is equal to this one. So microliter to nanoliter you need to multiply with 1000. Similarly, if you have microliters 10 raised to power minus 6 liters to milliliters which are 10 raised to power minus 3 liters, so you need to basically now divide by 1000, because your ml is a bigger unit and your microliter is a smaller unit on this very scale. For example, here we can say this is ml and this is microliter, and from microliter to milliliter you need to basically go the other way around. For example, if you're going this way around, you need to multiply, and if you are going to this way around, you need to basically divide. Similarly, milliliters to liters you need to divide by 1000. So that's how these calculations are done, and you can get expertise by doing such type of problems again and again, and you will have a very clear concept then. There are certain other calculations which have been performed for you here. This column is for volume and the other one is for the mass. So if we have cubic meter volume and we want to get liters here, what we need to do is, cubic meter is a bigger unit as we have seen in the last slide, and liters are 1000 times smaller units. We need to multiply volume in meter cubes to 1000 to get the liters actually. So 1.2 meter cube to liters is our first problem here. Here we can see 1.2 multiplied with 1000 equals 1200 liters. So this is the volume in liters. Similarly, if you have ml and you want to convert it to liters, ml are smaller units, liters are bigger units, so you need to basically divide with 1000. So 300 ml divided by 1000, you're going to get 0.3 liters. Similarly, 600 microliters to ml. Microliters again is a smaller unit, ml is a bigger unit, so from smaller to bigger unit you need to divide to get the required answer here. Okay. Similarly, if we speak of mass, 500 milligrams to 2 grams. Grams is a bigger unit, so you need to divide by 1000. So 500 divided by 1000 equals 0.5 grams. Similarly, if you want to convert 0.5 kilograms to grams, now kilogram is a bigger unit. Kilograms, 1000 grams, 2 grams. So we need to multiply with 1000. So we are getting 500 grams. Similarly, 300 nanograms, 10 raised to the power minus 9 grams, to micrograms, 10 raised to the power minus 6 grams. Micrograms are bigger than nanograms. How much? 1000 times. So if you want to convert smaller unit into bigger unit, you need to divide by 1000 here. So 300 divided by 1000 will give you 0.3 microgram is the answer here. This very slide, now we are moving forward to our first concentration term, which is molarity. And molar solutions are used quite a lot in solution chemistry, and molarity is simply explained by how many moles of solute are there in 1 liter of solution. This is a kind of weight by volume concentration. So weight of solute in grams by volume of solution in liters here. How many moles are there per liter of solution? As we know, the number of moles of any species, it can be computed or calculated. If we have mass in grams, we can divide that with molar mass of that very substance and we get number of moles. So if we put this expression into the above one, we can come up with a more refined version of molarity calculation, and that's just like this. We need mass of solute in grams, molar mass of solute, and volume of solution in liters. This is important actually here, because this very formula can be used to calculate if the volume is given in liters. So all we need here is mass of solute in grams, molar mass of solute, and volume of solution in liters. We can get molarity. In this very expression, we have molarity, mass of solute, molar mass of solute, volume of solution. So all these 4 components are there. We can calculate any one of them if we have the values for the other 3 components. Alright, if the volume is not given in liters, the volume is given in, for example, milliliters, then alternatively we can use this very formula. That's mass of solute in grams divided by molar mass of solute into 1000 divided by the volume of solution in ml. The only difference here is that the volume of solution, which was in liters, is now basically used in ml, and to basically compensate that, we have used that 1000 as a factor here. So these are the formulas which are normally used in order to practice different problems related to molarity. We have some solved examples here. Before we go to basically solution of these examples, first we need to also understand another concept of molarity, which is based if the solutions are at the micro scale. Here molarity is also equal to number of millimoles. Rather than moles, we are using number of millimoles of the solute per ml of the solution. So both the factors from this very equation are now reduced to, basically moles are reduced to millimoles and liter is reduced to milliliter. This is also basically molarity, the same concept. So if we basically rearrange this equation here, the molarity here, this factor is being divided, will be multiplied here by volume in ml of solution. If it is multiplied with molarity, then we can get number of millimoles of solute. This is another expression which is commonly used to calculate either of these 3 values if that is missing. For example, if we want to calculate number of millimoles, we must have volume in ml and molarity of the solution. Or if we want to calculate molarity, we must have number of millimoles and volume of solution in milliliters. So this is another expression you need to basically remember. There's a solved example here. How many millimoles of urea are there in 20 ml of its 2 molar solution? In all these molarity and concentration problems, before we really start solving that very numerical, you must identify the data which is provided in the question. For example, in this very question, we have to basically calculate millimoles of a certain compound, urea, are there in 20 ml of its 2 molar solution. So volume is given, molarity is given. Molarity is 2 molar, volume is 20 ml, millimoles of urea needs to be calculated. So we have molarity, we have volume, and we need to calculate number of millimoles, and molarity multiplied by volume in ml is equal to number of millimoles, which is 40 millimoles of urea, which are basically present in this very solution. So it's like this. Similarly, we have another question here which basically states that you need to calculate molarity of this very solution, and 20 grams of ferrous sulfate heptahydrated, it's dissolved in 500 ml. So total solution volume is 500 ml. Compound is given here, and mass of solute, which is FeSO4.7H2O, is 20 grams. So mass of solute is 20 grams, molar mass is computed here 276 gram per mole, and volume is 500 ml. What we need to basically calculate here is the molarity. So we are putting this equation here. Molarity is equal to mass of solute in grams divided by molar mass, grams per mole, into 1000 divided by volume of solution in milliliters. So this is milliliter formula with 1000 here. So putting all these numbers here, we are getting 0.14 mole per liter, or molarity of this very solution. I hope it's simple because we have data and we can basically calculate the required parameter here. Similarly, this very solved example is basically how many grams per liter of potassium permanganate are dissolved in 0.5 molar solution. We have molarity here, 0.5 mole, compound KMnO4, potassium permanganate, and what we need to calculate here is grams of KMnO4 per liter. All these given numbers are here. We need to calculate mass of solute in grams per liter. Molarity is 0.5, molar mass is 158 grams per mole. So we have a formula here that molarity equals mass of solute divided by molar mass. So we have just rearranged that first equation, which we have seen in our one of the previous slides. So what we need to calculate here is mass of solute in grams per liter is equals to molarity into molar mass of the compound. Molarity is given 0.5, molar mass is 158. So 79 gram per liter is the amount of KMnO4 dissolved in 1 liter of this solution if it has this molarity, and so on. So this was all about the basic concept behind molarity. We have some practice problems for you here. These are 5. You can basically do them as your homework. This is very simple, and the formula which we have just discussed here is to be used here. For example, in question number 1, we have to calculate the molarity of solution if it contains 30 gram of sucrose in 330 ml of soft drink can, and the quantity of sucrose there is approximately 30 grams. And sucrose is C12H22O11 with a molecular mass of 342 gram per mole. So we have molecular mass here, we have mass of solute here, we have total volume here, and we need to calculate the molarity. So simple equation will be used. You can do it easily. In the second problem, we have how much sodium chloride is required to prepare 0.2 molar solution of it in 500 ml. What we need to calculate is sodium chloride's mass in grams, so mass of solute. It's just like the example we have just seen. 0.2 is the molarity, 500 ml is the volume. Sodium chloride's molecular mass is 58.5, can be put there to calculate how much mass we need to dissolve in this 500 ml. Similarly, our question number 3 is calculate the volume of solution. So we need to calculate volume of solution. If we have 50 milligrams of glucose say 6H12O6, 180 gram per mole is the molar mass, and you want to use it to make 0.02 molar solution. It's a bit complicated problem, but you have molarity here, you have mass of solute here, you have basically molecular mass of glucose 180. You need to calculate volume of solution. Okay. Molarity of urea solution. This is the compound, molecular mass is given, and 3 gram of urea, mass of solute in grams, is dissolved in 500 ml. So you have volume of solution in ml, so you will use the formula to calculate molarity where volume of solution is given in ml.